Hello, this is Group 13. This is our group presentation on Bluetooth. I am Emmanuel Ortiz, and I am a CS major.
My name is Benjamin Quinn. I'm a computer engineering major.
Hi, my name is Tofong. I'm an electrical engineering major.
Hi, my name is Ross Parsons. I'm a computer science major.
So I will walk you through the introduction for this presentation. Bluetooth have been an integral part of communication between devices since 1999 with 2000. From the first launch product present on stage, the first Bluetooth hand-free mobile headset, as you can see in the picture. This one device ended up revolutionizing how devices communicate and how convenient products are nowadays. Bluetooth can be defined as a short-range communication module that can be found on everyday device from your smartphone, your printer, headset, or etc. This module create a radio frequency that is around 2.4 gigahertz and can create agreement to at a protocol level that agree between products when bits are sent. No line of sight needed. This make module very sought after. It is not only much more convenience due to wireless capability, but inexpensive and automatic as well. So the other part of the introduction, Bluetooth feature great characteristic such as quick pairing of hosts to another device, protection data stream, void of stealing information, eavesdropping through encryption and authentication. Connection can stay open for however long the device is paired for. Reliable delivery of any package information. Mixed master slave mode allow for multiple connection to multiple sensor operating in either master or slave mode. Bluetooth 2.4 gigahertz frequency and few often refer as ISM band, which is known as industrial, scientific, and medical device. As of 2009, Bluetooth integrated circuit shipped approximately 920 million unit annually. Range vary depend on propagation condition, material coverage, antenna configuration, and battery condition. And Bluetooth have three classes.
So the three classes of Bluetooth, well, classes refer to the Bluetooth chip specification of the device. In other words, the power output. So the class 1, class 2, and class 3 uh, each have different power transmitting capability. So for the class 1 range is 100 meters, um, or 333 feet, a power of 100 milliwatts. It's used in industrial applications, uses high battery. Battery consumption is much higher and therefore requires plugged in. Any Bluetooth device that's using class 1 has to be plugged into a power source. It's also used in the industrial Internet of Things, which we'll get to in a bit. Class 2 devices, the range is 10 meters or 33 feet. The transmit power is 2.5 milliwatts, and it's used in most cell phones and speakers. Class 3 Bluetooth module has a range of less than 10 meters. Power transmit is small at 1 milliwatt. Very uncommon. So the class 1 Bluetooth, most end users won't use a class 1 device directly. They're mainly stick with class 2 and sometimes class 3. But well, class 1 is used at the industrial level. So one use case is in manufacturing. That includes helping manufacturers better monitor location, availability, and condition of equipment and output across the supply chain. On a side note, Class 1, they found a use case for it, and in chemical labs, what they've done is they've put in Bluetooth, and employees will wear a Bluetooth beacon, and so any room in the chemical lab that has highly reactive chemicals or flammable chemicals, they can monitor how many employees are in each room, just to avoid a cluster. So Bluetooth mesh networking was also developed by the Special Interest Group, which is part of the Bluetooth organization. And what the Bluetooth mesh networking does, it enables many device communication. So hundreds to thousands of devices can communicate simultaneously. They found applications in control systems, so lighting control for smart buildings, monitoring systems use Bluetooth wireless sensor networks, so they can monitor lighting, temperature, humidity, occupancy to improve employee productivity and lower building operating costs. So, at a certain, if the weather changes and gets very cloudy, sun goes down, they find that, the AC doesn't need to be revved up, so they can lower that to accompany the changing weather, therefore save money. Automation systems that enables automatic control of buildings' essential systems, so lighting, heating, ventilation, and AC for energy saving. Class 2 use cases. Now, this is the Bluetooth that most people are familiar with. Since most Class 2 Bluetooth devices are battery powered, virtually all cell phones or headphones and speakers today will employ the Class 2 Bluetooth. The range is 10 meters or 30 feet, which is fine for most users doing the basic tasks required. Bluetooth device, such as listening to music, controlling TV, sending data from one device to another. Class 1 and Class 2 devices can connect with each other, but the range will revert to the device with the lower class. So a Class 1 can send data to a Class 2, and a Class 2 can send data back to a Bluetooth module using Class 1, but it can only do so at the distance specified from the Class 2 device. Now, if you just want to send information from a Class 1 module down to a Class 2 and not receive data back, you can do so at 100 meters. But obviously, Class 2 device cannot retransmit data back. Now, one big achievement in Bluetooth has been the Bluetooth Low Energy, or BLE. In the past, devices would rapidly deplete battery power when they had their cell phone, when someone's cell phone had Bluetooth turned on. With this BLE, the device doesn't actively try to initiate a connection every time it's in range of a Bluetooth device. And also, energy is only used when data is transferred. So when you have it connected to a speaker, music is not playing, battery is draining. Class 3 use cases are funny. Like I said before, Class 1 and Class 2 can't communicate with each other. And the same goes actually for Class 3. So any of these Bluetooth classes, all they really are referring to is the power output, but all the protocol is the same. They all operate within that 2.4 gigahertz. So they can communicate fine. It's just distances is what's different. And so Class 3 is going to be, 1 milliwatts, can use low power. It's going to have low range, It's used for wireless mouses and other small devices. It's used in the Internet of Things. So a device like the Ring doorbell with the camera. So the doorbell and the camera can communicate with very short distance, about a couple feet, if the two aren't built in. So you have the configuration with the doorbell and camera built in. You won't need to use that Apple mouse. Apple in the past has used Class 3 in a lot of their mouses and etc.
So the evolution of Bluetooth technology. In 1998, a group of 5 companies formed a Bluetooth Special Interest Group, also known as SIG. They tried to harness the power of Bluetooth technology. In 1999, SIG introduced Bluetooth 1.0, earned them the top honor at the Comdex show for Best of Show Technology Award. In the year 2000, PC car introduced with integrated radio frequency and Bluetooth wireless software. Is also seen at first used in headphone and mobile phone. In 2001 to 2003, the technology of Bluetooth spread like wildfire. First, Bluetooth printer, laptop, camera, keyboard, medical device. So 2004 was the introduction of Bluetooth 2.0. It supported an enhanced data rate up to 3 megabits per second. 2009 we get Bluetooth 3.0 feature with high-speed data transfer that use 802.11 Wi-Fi radio could reach speed of 24 megabits per second. And in 2010, you get the Bluetooth 4.0, also known as Bluetooth Smart, improved connectivity, range, and low power energy protocol. 2013, Bluetooth 4.1 come with better speed in direct IoT device connection. And 2014 is when we see the Bluetooth 4.2. It get rid of the range barrier by allowing device use Internet Protocol version 6 for direct internet access. This increased the capacity for data package by 10 times and increased speed by 2.5 times faster than previous version. In 2016, we see the Bluetooth 5.0. It came with improved in every factor, double the speed, range increased by 4 times, and 8 times more capacity. This makes device more responsive, and you have the range estimate up to 120 meters.
Some definitions. So some common definitions you might hear: radio frequency or RF, oscillation rate, current, voltage, electromagnetic radio waves working in a frequency range, commonly used for communication, generated by Bluetooth and other transmitters and receivers. Piconets or Bluetooth networks, these use a master-slave model that controls sending data. A single master device can be connected to multiple other devices. Pairing creates a connection to another device, shares addresses, names, and other information that is then stored in the memory of the device. Some other definitions: data encryption, translating data to another form. Only people with access to a decryption key or password can read it. Encrypted data is referred to as ciphertext. Unencrypted is referred to as plaintext. Serial communication, sending data one bit at a time over a communication channel or computer bus, mostly used for computer networks and long-distance communication.
Alright, I'm going to talk about the relevance of Bluetooth and common practices. So Bluetooth technology has a lot of advantages. It is low cost, it's low power, and it requires no routers or modems. All you need for two devices to be able to communicate with each other is for both of them to have Bluetooth capability, which, because it's cheap, is easy to give to a lot of devices. You can even give it to a printer. You can print documents and images via Bluetooth if your printer is Bluetooth enabled. This is why it's used in all sorts of devices: mobile phones, computers, cars, and some medical devices for monitoring patient vitals and things like that. Another advantage Bluetooth has is that all types of data can be transferred through it: voice, music, video, anything. And of course, this was the technology that enabled the very first wireless headset. Basically, Bluetooth works like a wire, just you don't need to physically connect anything, and the data transfer rate is a little bit slower. It also supports encryption for data protection. One of the issues that you can come across with Bluetooth is that it has a fairly narrow operating band of fairly normal band of frequencies that it operates on. It goes from 2.4 gigahertz to 2.485 gigahertz, which is fairly narrow. So to deal with this particular issue, it uses spread spectrum frequency hopping to avoid devices interfering with each other when many of them are communicating in the same area at the same range. How this works is the two communicating devices figure out which pattern they want to cycle through, and then they will hop frequencies together. The transmitter will say, if we're using this graph as an example, the transmitter will start off for time interval 1 at 2.4 gigahertz. At time interval 2, it will jump to 2.3 gigahertz, and so on, back and forth. And then once it reaches the end, it'll cycle back to the beginning and continue along in that pattern to avoid reader collision, to avoid multiple Bluetooth devices operating in the same area from interfering with each other. An interesting exploit we've learned about with Bluetooth was called the Car Whisperer. It's an exploit found by the Tri-Finite Group in 2005, which is a group of European wireless security experts, basically hackers. And it takes advantage of the fact that most car manufacturers use simple 4-digit security keys to set up the Bluetooth wireless communication in their cars. Typically, it'll be something like 0000 or 1234. Now, the hacker can take advantage of this to get in pretty easily, and they can connect to the hands-free Bluetooth in the car. They can eavesdrop on whatever's going on in the car, or even talk to the driver. The software the Tri-Finite Group published that does this has a pre-recorded message saying, basically, this is the Tri-Finite Group's Car Whisperer, please drive safely. It's worth noting that this is just for hands-free communication. This doesn't get the user into, for example, the brakes or allow them to deploy the airbags. Basically, it just allow people to talk or to listen. And an issue that you can come across when trying to hack into a car is that the range is quite short on most Bluetooth devices. The most common type, Class 2, has a range of about 30 feet. So in order to combat this, the Tri-Finite Group developed something called a Blue Sniper rifle, which has a range of up to a mile away. This is a picture of the Bluetooth Sniper rifle here. The white part you're seeing on the end behind his back is a directional antenna, specifically a Radome Yagi antenna. It is bolted to a Ruger folding stock, and what he's holding there, that little chip, is a Gumstix embedded PC. The Gumstix embedded PC is the brain of the little rifle, and it is mounted in a little magazine at the bottom of the stock, and that little embedded PC talks to a laptop running Linux so that the user of the Blue Sniper can interact with the data he's found on the laptop. The entire thing is powered by 3 AAA batteries and has an expected lifetime of 6 to 8 hours when operating. They did a test shoot with this to prove that it worked in downtown Los Angeles. Pointed it at some skyscrapers like the ones you can see in the background, and they successfully connected to something that was later verified to be 3/4 of a mile away. Now, while Bluetooth does have a lot of advantages, there are some disadvantages. One of the biggest ones is both of the big ones are a result of Bluetooth operating in a low power mode. So the low power mode limits the range the Bluetooth device can operate at. So as a result, when two devices that both share short operating ranges are connected, it's very easy for them to become disconnected by users, for example, taking a few steps in the wrong direction. Same sort of thing will happen if you, for example, are listening to music through a Bluetooth headset and the music is playing on your laptop. You could leave the laptop in your room, walk into the kitchen, and that would be enough to cut off the signal and stop the music. Also, because of the low power mode, it has a very slow connection data and transfer speed compared to Wi-Fi. Bluetooth packets are much smaller, take less power, go a lot less distance, and generally just transmit less data, contributing to an overall slower data transfer speed compared to Wi-Fi. As well as that, it does not have very much good security in it. Wi-Fi has better security than Bluetooth does. Bluetooth is easy to hack into. The real saving grace of the technology is that it's a limited range, so hacking into Bluetooth usually involves getting closer to the device you actually want to get to, whereas it's a little easier to get anywhere with Wi-Fi. Another downside is that if you have Bluetooth enabled on a device, it will continually be scanning for nearby devices and as a result will drain battery, as well as take energy to transmit signals when you are actively using it. And the final downside is that it is easily interfered with by other devices because the 2.4 gigahertz to 2.485 gigahertz frequency band is very commonly used. As well as that, it will also have reader collision interference problems if you have multiple Bluetooth devices operating close to each other within each other's range. This means that it's easily picks up interference from other Bluetooth devices, from Wi-Fi, from microwaves, etc.
Hello, this is Emmanuel Ortiz. I'm going to be talking about the coding examples and how simple the Arduino IDE makes using the Bluetooth module. Firstly, this code connects the Bluetooth module to the ping sensor, allowing for communication between them. If you look at the code in the image, you can see a function called serial is being used. This is one of the main functions that are going to be used to communicate between devices. It mainly controls the connections between the serial ports, also called the UART, and has several important functions. Let's go through some of the functions listed in the image, such as if serial. This indicates whether the serial connection is open and will return true if the port is available. As used in the code, if serial available is greater than 0, which will come true if one or more ports are available. And the if statement is proven, the serial.read function comes into play, which feeds in information through the port and can save that information into a variable. Digital write works with either an input or output, but the first variable should be decided earlier on in the code as an input or output. In this picture, we're assuming that LED as output to turn it on and off, high and low, which are the only available options for the second value. That image gave us a basic template on how to write our code for our mini project and what libraries would be important to include. Now this example may look somewhat the same, but works with a separate connection. This code can connect a Bluetooth device to the microcontroller through the module. This is a flexible template that will be used on our project to connect a smartphone to a microcontroller and work remotely through it. Though there is another difference in this code, which is serial.begin. This sets the baud rate, the rate at which information is transferred in a communication channel of the serial transmission. Baud rates are different for multiple devices, but for Arduino and Bluetooth, the default range is 4,800 to 38,400. Though if the baud rates are too high or too low, problems with the transmitter or receiver will occur in forms of bit error rates. There are also some libraries that you can download for the Arduino IDE if the baud rate isn't given, and they also allow you to set module communication speed to anything the user would want. There's also functions in those libraries that allow you to test for connection through the pins and return true if Bluetooth is connected. Now, challenges and opportunities, the pros and cons of working with Bluetooth. Firstly, using Bluetooth shortens battery life, though there are low power options for Bluetooth if dealing with small packets of data. Slow data transfers, due to its model of being very low power, it can only reach a certain amount of megabytes per second on data transfer speeds. Bluetooth data security. In most cases, Bluetooth can keep your information secure through encryption, but with most wireless systems, there's always a flaw that will allow exploitation, as mentioned before. Bluetooth has been under attack plenty of times with tens of different ways, such as blue bugging, which allows the user to access your phone without you noticing when they're sitting right next to you. And last year's Blueborn attack, which was a virus that can get into your device through Bluetooth through frequencies, and the person who commenced the attack will have full access to your phone without having to pair. Another challenge is its very limited range. Due to its low power operating mode, the range can be very limited depending on the class of Bluetooth. Also, since Bluetooth uses the 2.4 GHz frequency, it is often interfered with, as mentioned before. Now the opportunities. Bluetooth is compatible with other parts. This allows for easy creations or access to wireless connections. multiple pairing partners that allows multiple devices to connect to a singular master device. This can be useful with Bluetooth multipoint, since you can have multiple connections to, let's say, for example, a headset. You can not only stream music from your phone, but also listen for ping notifications on your laptop. Also, having multiple pairings available makes pairing to an already recognizable device easier to access without having to go through the pairing process. Bluetooth is an everyday device nowadays, which gives us free reign to be able to connect any created product into any device if needed. And it's also extremely user-friendly, just a few simple clicks, and you can send or receive data easily. We have placed a few resources here that will help you understand more about Bluetooth and how it works. The first link is a write-up about the challenges of building a Bluetooth-based product, and it not only breaks down how Bluetooth works, but also how to deal with some of its shortcomings. The second link explains Bluetooth in a more accessible and shortened way than the first link, informing the reader in summarized definitions of intricate protocols and processes. The third resources is mostly for the HC05 Bluetooth module, showing the reader its specifications and configuration, also how to properly prepare the module for use. The fourth resource shows a support one can get from Android devices with specific APIs that can be used to connect to a Bluetooth device. This will help any program creating an application quick access to Bluetooth communication through setting permissions, using specific calls for the Bluetooth adapter, and discovering and connecting other devices. The fifth resource is mostly explaining how to set up your application for Bluetooth connection through Android Studio. Lastly, our questions. What is the latest Bluetooth version? What frequency does Bluetooth operate in? Can you name the 3 issues that Bluetooth have? Difference between Bluetooth classes? Define PicoNet? And what are some pros and cons of using Bluetooth in place of Wi-Fi? These are our references. And this has been Group 13's Bluetooth group presentation. Thank you.